Namaskar, good morning. I am Dr. Renuka Sagar, working as professor in the Department of Artificial Intelligence and Machine Learning at Ballari Institute of Technology and Management. I would like to introduce a few of my pedagogical techniques introduced during my teaching profession. Higher educational institutions, every course, if we take, AICT has introduced, in line with the National Education Policy, all the courses will be of two categories. One is the problem-based category and the other one is theoretical-based category. Problem-based is numerical approach, and theoretical-based we have the algorithm approach. So for the students, in that case, problem based will be very challenging for the students, because they don't feel interested in solving it. Most of the students, they lag in problem solving. So the idea which I have incorporated during my subject, that is digital signal processing, which I have taken it as a part of my workload, is that I make the students to prepare charts, and all the students, they have to make teams. In that team, I group the students into weak as well as strong learners, and I have insisted the students to prepare the formulas, step-by-step procedure to solve that particular problem, and what are the important substitutions that they need to incorporate to simplify at each and every step until it reaches a final solution. So all the important steps which are required for a problem solving will be neatly drafted in the chart, and every day each student has to recite what has been written in that particular chart. So every time the student recites, weak learners, if the student is little weak in understanding the concepts, he will remember the formula and he will know where to apply this formula and what are the substitutions that he has to do it to find the solution. In that case, let me take an example of designing a Butterworth low pass filter in the subject called digital signal processing. That is a very challenging and difficult thing. So what I do is, using this particular procedure, there are many calculations actually involved in the designing the Butterworth low pass filter. So like attenuation constant, gain and all that. So using this approach, the student will actually know how to first understand the problem statement and what formula to be chosen for the particular design specifications, and what has to be written as the first step, and what is the next step that he has to go do it. So these kind of practices will actually make the students to at least clear the subject with confidence and not having a backlog of this difficult subject, and slowly incorporate the similar kind of procedure with a little complex problem. Increase the complexity of the design specification, and wherever there are any changes that needs to be made, that is again done in the next further classes. The same procedure is followed for the entire course. And if the students are very good learners, strong learners, for them what I do is, after the student find a solution for a particular problem which is given in the class, slowly I will guide the students to convert the same mathematical procedure which they have done it into a coding part, that is the MATLAB code. So this particular approach, if they are able to build a mathematical model for the problem which I have given it in the class, then as a third approach, what I would do it is, I would take those students into confidence, and I will ask them to collect the few more problem statements from Smart India Hackathon website, DRDO, ISRO, and get the mathematical approaches find the solutions based on the mathematical concepts for the problem statements given there. So, and then they have to convert that mathematical concept into a code. So this is what a mathematical model is built, and finally the student will be guided to do a very good paper for publishing also. So this is one of the approach which I do it for the problem based subject. And when it comes to theoretical based subjects, that it is every theory subjects in the due course of higher educational institutes, they have algorithms as a part of their curriculum. So when it comes to algorithm based, it is very important that the algorithm has a function code, and students will not be interested to understand how that code actually works. So what is the thing which I have done it in a subject called as artificial intelligence, which I am currently handling also. So there are many AI algorithms in that particular course, and it is very important for the students to learn those algorithms. So I have introduced the virtual labs as one of the pedagogical techniques to make the students learn the deeper concepts of the virtual labs. So in the virtual labs, under the Ministry of Education and the National Mission through ICT tools, we have different experiments for each and every course. That is, in the AI algorithms, we have breadth first search, depth first search algorithms. So the students will be through the virtual lab, sitting at classroom, sitting in the classroom, they can just open their laptop, and you don't have to log in or give any credentials also for that. They can get into the computer science and engineering branch, and click on the artificial intelligence laboratory component, and there they'll be directing to the AI algorithms, where they can simulate a graph, they can create a graph, start the algorithm, how to learn how the algorithm traverses until it reaches the solutions. So this kind of visual representation what virtual lab is providing for all the students is actually giving a very good insights to the students to enhance their learning. Virtual labs is neatly drafted with theory. There are some theory points and procedures also, how to experiment that particular course, and there are small tests also. Students will be asked to go for a small test at the beginner level and also at the intermediate level, and few demo tests can also be done with a particular course, and then they can go for the practice. I give the practice examples so that they can take another particular problem statement and continue to approach the same algorithm and see how the algorithm is functioning, and how the graph is traversing and all that. And finally, whatever the output they get, they can also contribute to the portal. So this actually gives a student a very good understanding about the subject, and also because they are doing it virtually, they will have a deeper core concepts. And second important thing is because they observe how the simulation is going on, which parameter has to be changed, if I change this parameter, where it is affecting. All these kinds of knowledge what the student gains through the virtual labs are exceptional. So these kind of approaches I will incorporate in my courses as a regular practice, and I am actually getting a good inputs from the students also. Like, students are getting good scores in their internal assessment and also at the semester end examination, and also they would like to continue with their mathematical building their mathematical knowledge very, very strong in these by using these methods. Thank you.